Hi guys. In this video is we're going to talk about how to solve a work-related problem as it relates to calculus. So let's start with the basic work that required to lift a 5 kilogram book 2 meters high, so above the ground. So if you wish to calculate the work done by constant force, the work is equal to the force multiplied by the displacement, and you need to know that force is mass times acceleration, and the acceleration in the y direction is g, which represents gravitational acceleration. So for this problem, replacing f which with mg, the work required to lift something, the mgdm is the mass in kilogram. That's 5 kilograms. G is the gravitational acceleration. That's 9.8 meters per second squared, and d is the distance in meters. 5 times 2 is 10, and 10 times 9.8 is 98. So the answer for part A is 98 joules. And that's it now for part B. How much work is required to lift a 30-pound box? So 4 feet off the ground. The units are different now. So when you see the weights in pound, this doesn't represent mass. So weight is a force. So all we need to do is use the equation. So the work done is going to be the force of 30 pounds multiplied by a distance of 4 feet. So 30 times 4 is 120. So it is going to be 120 foot-pounds, which is another unit of work number to find the work done in pushing a car. So distance 50 meters. Excuse me. So the distance 50 meters with constant force of 400 newtons. So anytime you wish to find the work done by constant force, so you can use that equation. So the force is 500 newtons and the distance is 15 meters. So we can just simply multiply those two numbers, and don't forget the newton times the meter is a joule. So the work done is going to be 7,500 joules. And that's all we need to do for this problem. Number 3, variable force in newtons acting on an object represented by a function of f is equal to x squared minus 1 plus x is the distance in meters from origin. So how much work is required to move an object from x equal 1 to x equal 4? So the work done by a variable force is the defined integral from the a to b of the force function times dx. So in this case, a is 1 and b is 4 based on the values that you know. So f of x is x squared minus 4x plus 1, and the derivative of x squared is x cubed divided by 3, and the derivative of x is x squared over 2. The derivative of 7 is x. So let's evaluate the 1 to 4. So if we plug in 4, it's going to be 4 to the third over 3, and then 4 divided by 2 is 2. And then times 4 squared plus 7 times 4. Then we need to plug in 1, so it's going to be 1 over 3. And 2x squared, so 2 times 2 times 2 minus 7. So now let's combine like terms. So we can combine these two. 64 minus 1 is 63. And so that's 63 divided by 3. Negative 32 plus 28 is negative 4. And 7 is negative 5. Now 63 divided by 3, that is 21, and negative 4 minus 5 is 9. 21 minus 9 is 12, so the answer is 12 joules. Number 4. A force of 50 pounds is required to hold a spring stretch 5 inches beyond natural line. So how much work is required to stretch it from its natural life to 10 inch beyond its natural life and foot pounds? So let's talk about spring. So let's say that this is a spring that it is natural state. In order to stretch a spring is you need to exert a force, and in order to hold at this position, so you have to apply a certain force to the spring. You want to snap back, and so there's a restoring force that wishes to pull it back. So to calculate the force that is required to hold at the new position, that force is equal to the spring constant times x, where x is the distance between its natural length and its current length. Now is k is a constant, and k can be found by taking the force divided by x. So the problem we need to find is k pounds of force is required to stretch the spring 5 inches beyond its natural length. So x is 5 and 50 divided by 5 is 10. So basically k is 10 pounds per inch. So now we have k, we can write the force as a function of x. So it is going to be k times x, or 10 times x. So that is the force required to stretch in the spring at any distance x from its natural life. So if we want to stretch, let's say 20 inches from its natural length, the force would be 10 times 420, or 200 pounds. So now we can calculate the work by that. This is going to be the definite integral of f of x dx. So we wish to calculate the work required to stretch from its natural length. That's when x is 0 to 10 inch beyond its natural length, which is x is 10x, and the distance from the natural length to its current position. So the work is going to be the integral from 0 to 10 f of x, which is 10x times dx. And the antiderivative of 10x is going to be 10x squared over 2. And so 10 is divided by 2 is 5. So it's going to be 5x squared evaluated from 0 to 10. And that's 5 times 10 squared minus 5 times 0 times 5 is 100. So it's 5 times 100, which is 500, and the units are pounds times inches. Now I wanted to convert it to pounds times feet. So 1 foot is equal to 12 inches, and so the unit inches will cancel, and it becomes 500 divided by 12 foot pounds. Now we can reduce 512. So 500 we can write as 125 times 4 and 12, as we can write as same as 3 times 4. So we could cancel a 4. So the final answer is going to be 125 over